All right, starting with blue. Okay, so about 60% of this stuff is review from Algebra 1. 40% of the stuff is kind of new. We're adding some things in here, okay? But we're going back to systems. So a system is just when you have more than one equation, okay? And if someone says solve a system, that means, so solving a system means find the point where the lines do what? Intersect, yep. So we want to find the intersection point. That's the goal. Okay, find the intersection point. Okay, so we get a chance to try this with all of the forms of lines. So I'm gonna color code my system. I'm gonna choose to do my first line in blue. So by graphing means we're just gonna graph each line. Okay. All right, now I've built your toolkit. For this purpose, you think, what's the most efficient way for me to graph that? Maybe intercepts, right? If we graph the x-intercept, we plug in 0 for y, so I'm just going to cover it up. What's our x-intercept? 6. So I know that I have an x-intercept of 6, 0, and if I go to do the y-intercept, I'll plug in 0 for x, or I'll cover it up, and my y-intercept is also 6. Right? Okay. And then I can calculate my slope. -6 over 6 is -1. So this is our first line. It's just got a nice little down 1, right 1 slope. Make that as straight as I possibly can. Okay. Okay. Then I'm going to do the same thing with the second line. And the second line, I'm going to do that one in green. And the second line is in point slope form, right? So I got to pick out the given point because that's the one that I'm going to start with. X1, Y1 is -4, -4, right? So I'm going to start there. And our slope is 3 over 4. So we're going to go up 3 and right 4. And even if you see the point where they meet, you still have to finish the line, okay? So up 3, right 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. All right. Whoops. Okay. Pretend that I actually drew that. That I actually made my line go through the point. It's kind of hard to do on the board. Okay, well ideally, we see where they intersect, right? Okay, so this guy right here, where the point where they should have intersected, that is the solution. Okay, the solution is the entire point where they meet. And what is that coordinate point?
4, 2.
4, 2. Okay, now. That's the solution. So on the line for a solution, I put the coordinate point 4, 2, but I'm going to add something to this, okay? In our class, the whole course, from now till the end of May, if we're being asked for a solution, our solutions go inside of solution sets. And solution sets are these curly braces. It's set notation. Okay, the reason this is so important is because eventually we're going to be solving things that have multiple solutions. So we would be putting multiple things in these solution sets. Okay, so that is this, if you need a little note, that right there is called a solution set and it is required for solutions. Okay? That just means, hey, whatever's inside of here is the solution, okay? All right, that's one thing that's new from Algebra 1. The other thing is the label or the category of system. We're gonna give this a name, all right? And I've got a little explanation here. So a system of equations that has at least one solution is called a consistent system. So if there is an answer, we refer to it as consistent. If it has exactly one solution, it is also called independent. So this one, if we asked to categorize or name it, its category would be called consistent, independent. I mean, we didn't talk about this, but those lines will never meet again, right? They met one time and, yep. Independent. Independent. Okay, so the solution set is new and the label is new. Okay? All right. Now let's do this again with number 2, example 2. All right, so we're going to solve this system. Okay, so let's say I'm going to also do intercepts. This first one is standard form, and I want to do intercepts. And let's say I start with, okay, let me figure out my x-intercept. I would plug in 0 for y. I'd be looking at 12x equals 27. But what's going to happen there? Yeah, it's not going to divide evenly, so my x-intercept is not going to be a very nice number. Okay, so scratch that. I don't want to do the x-intercept. What about the y-intercept? Will that be nice?
Yeah.
Yeah. Plug in 0 for x. I'm looking at negative 9y equals 27. And then just divide by negative 9. Y is negative 3, right? Okay, cool. So the y-intercept is 0, negative 3. And then I can use my shortcut to figure out the slope, right? Opposite A over B. Negative 12 over negative 9. So that's going to be a positive, divide by 3, 4 over 3. So we have a slope of 4 over 3, okay? So we go up 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3. Cool. 4, left 3. All right, okay. Let's see. Okay, that isn't terrible. There we go. Okay, I'm going to do the same thing with the second line. Now, just to be different, I'm going to choose on my second line to convert this into slope-intercept form. Okay, so let's say that's the route I want to go. I would subtract 8x from both sides. And then divide everything by negative 6. So then the slope-intercept form would be, excuse me, negative 8 divided by negative 6 would be positive, bless you, 4/3 x. And then 18 divided by negative 6 is negative 3. Now, what do we notice? It's the same line, right? Okay, so we don't have to graph that again. We know it's the same line. Here's how you show that you just graph the same line again. You just add another set of arrowheads, okay? That indicates that you graph that line 2 times, okay? I mean, you're welcome to do it all over again if you want to, but you don't have to. Okay. Now, now I got a bone to pick with your Algebra 1 teachers. All of them, whether it was here, whether you had it in middle school, because what do y'all thinking the answer is? And it's not your fault. What do you think it is?
Infinite amount.
Infinite amount of solutions, right? Okay. All right. Let's say you ask me, Miss Genzer, who is your sister? Ask me that question.
Miss Gerda, who is your sister?
1. 1. Like, that makes 0 sense, right? I just replied to her question with a number. I said how many sisters I have. That's true. I have 1 sister. Okay, but she asked who she is, right? So I should have responded Amy, because that's her name. Okay? So when the question is, what is the solution? And you say infinitely many, that's like that's the same thing. You answered with how many there are, but you didn't answer with what they are. Do you see the difference? Okay, so yes, there are an infinite amount of them, but what are they? They're all the points that exist on that line right there, right? Okay, so here's how we actually answer this question. How they should have taught you in Algebra 1, all right? They probably don't because they don't do set notation. Okay, so we're going to open our solution set, right? Our solution is all the points x comma y. So we're going to say x comma y in our little ordered pair such that those points live on the line y equals 4/3 x minus 3. That is how I say what those solutions are. They're all the points x, y such that y is equal to 4/3 x minus 3. Okay? So anytime you have this, you do this exact same thing. You just write the equation of the line in this part. Okay? Ugh, okay. All right, now let's talk about its category. Remember, we give the word consistent if there is an answer. And there is an answer. There is a solution. So this guy still gets to be called consistent. Okay? Still called consistent. But there is not just one answer, right?
Yeah.
So we don't use the word independent. We call it consistent dependent because there's an infinite amount of those solutions. Dependent. Okay? Now if I ask you how many solutions does this have, then you would say infinitely many. But what are they? That's what they are. That's my sister's name. Okay? That's not really her name, but you get it. All right. Now I bet you can guess what this one's going to be, but let's graph it. Make sure we are all on the same page. Okay? Last case. And let's put them in slope-intercept form. I'm going to convert both of these into slope-intercept form. So we would move the x on the other side, right? So 6y equals negative 4x plus 18. And then divide by 6. So we get y equals negative 4 over 6 is negative 2/3. And then 18 divided by 6 is 3. Okay? So y-intercept of 3. Slope of negative 2 over 3, so we go down 2, 1, 2, 3. 1, 2, 1, bum, 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 bum. 1, 2. Okay. Here's my first line. Okay. Now I do the second one. I'm going to do the same thing. I'm going to get slope-intercept form. So I'm going to subtract 6x from both sides. So negative 6x plus 18 on the other side. And then divide by 9. So y equals, that's also negative 2/3, right? Negative 2/3 x. And then 18 divided by 9 is
Or no,
2. Yeah, that one will be 2. Oh. So, this is super annoying, especially on your little paper, right? Well, what kind of lines are these?
Parallel.
They're parallel. We know all about that, right? Same slope. Okay. So when do these two lines meet? Never in their dreams, right? They are never going to touch. Okay. So if the solution is the point where they intersect and they don't intersect, that means there's no solution, right? Okay. Now the way we say no solution is not with the words. We got to use set notation, okay? There's two ways to say no solution. The first way is my favorite because I don't know why I think it's hilarious, okay? Here's a solution set. I mean, it's literally a solution set with nothing in it. Empty set. Like, here's the answer. There isn't one, right? That's called an empty set. So you can say no solution with an empty set. Another way you can say no solution is another set. It is the null set. So it's like a circle with a line through it, kind of like a no parking sign, something like that, okay? So pick one, but you can't do them both together because that's not a thing. So either empty set or null set, they mean no solution, okay? Okay, so if we call systems who have a solution consistent, and this one does not have a solution, we have to call it the opposite of consistent, which is inconsistent, okay? So this guy is just considered inconsistent, and that's it. Well, inconsistent. Whoops, I need a T there. Spelling is hard sometimes. Okay, inconsistent. Okay? So, sometimes we care about the actual solution. And sometimes we just care about, theoretically, how many solutions there are. We don't necessarily, we might not need to know what they are, okay? So, I think it's on the back for you. We're gonna come down here in this table and we're gonna summarize our 3 different scenarios, okay? Because sometimes I don't care about you actually solving it, okay? So example 1, look back at example 1, what was going on there? We had 2 lines that met one time, right? Okay, so I'm gonna go down here and I'm just gonna draw a sketch of what that looks like. So just 2 intersecting lines, right? They meet one time. Just a little sketch. Okay, slopes and intercepts. So for lines to intersect one time, their slopes have to be different, right? As long as their slopes are different, at some point they will run into each other, okay? I don't want to say that their y-intercepts have to be different because it might be that they intersect at a y-intercept, right? But every single time, the slopes have to be different for them to intersect. So right here, I'm going to put M1 does not equal M2. That means the slopes are different. Okay? And the name, what we called that consistent independent, right? And then for number of solutions, that there was 1, right? One solution. One solution. Okay. Example 2, we'll refresh that. That was the one where we had overlapping lines, right? Okay, so that was the same line, so we can sketch that as a line with 2 sets of arrows. Okay, their slopes were equal, so I'm going to put M1 equals M2. What about their y-intercepts?
Yes.
Also equal, right? B1 equals B2. Okay, and we called that one consistent dependent. And number of solutions, that one is infinitely many, right? Infinitely many. And lastly, we had a couple of parallel lines, right? Couple of parallel lines. Okay. And in that case, the slopes were equal, right? M1 equals M2. What about our y-intercepts? Not equal. So B1 does not equal B2. That's how we get parallel lines. That one was called inconsistent. And number of solutions? None. Zero, you could put the word zero, or a zero, yeah, or none. There are no solutions. Okay? Okay, so part of what we're gonna do is be able to classify without graphing, okay? So I'm gonna do example 4 with you, and then I'll let you try 5 on your own to see if you've got it, because this stuff is new, right? Okay, so it says without graphing, is the system consistent independent, consistent dependent, or inconsistent? And it lays it out, helps us, we can figure out our slopes and our intercepts here, okay? All right, so if I go for this first one, at first sight, that sort of looks like standard form, but it's not, because X and Y are switched. So I'm just gonna put this in slope-intercept form. Because all I have to do is add 2x and then divide by 4. So y equals 2x plus 6. And then divide by 4. So then y equals, I don't know why I crossed that out. It doesn't cross out. It's 1/2 x plus 6 over 4 is 3 over 2. So our m1 is 1/2. And our b1 is 3 over 2. Okay, and I can do that with the second equation. X is already living on the right side, so all I need to do here is just divide everything by 8. So that one becomes y equals 4 over 8 is 1/2. And then negative 12 over 8, let's see, you can divide those by 4, so 3 over 2 minus 3 over 2. So this one has an m2 of 1/2 and a b2 of negative 3/2. Okay, so without graphing, I notice, all right, m1 equals m2, but does b1 equal b2? No. All right, so that means, yep, inconsistent. So this one is inconsistent. Okay? Okay, so you try that for example 5. So do the exact same thing, come up with the slopes and intercepts, and then see what the classification would be. 17 minutes. Okay, cool. Just make sure
That's 2x.
Is Caitlin here? No. Eileen, are you here? No, I didn't think so.
Oh, hello.
So I will say, like, your strategy to find the slope and the y-intercept, if they're in standard form, you have a choice, right? You can convert it to slope-intercept, or you can do opposite A over B, you can do intercepts by plugging in 0, so you have choices. All right, so for this one, M1 did not equal M2, right?
Yeah.
So that means this one,
Consistent independent.
consistent independent. If the slopes, oh, not equal, sorry, I put an equal sign, not equal. So this one is consistent, independent, meaning there is one solution. Those lines are gonna run into each other one time, okay? Notice I'm not finding out where that is, but that's how I answer that question, okay? Okay, last thing we have to be able to do, and this should be pretty quick, is just creating a system from a word problem, okay? And these typically, the way you solve them is with a calculator, because sometimes they get kind of crazy to try to graph by hand. Taylor Swift Ed Sheeran hosting a charity concert. They're selling VIP passes and regular tickets. Each VIP pass is $15.
In what world?
All right, in what world? And each regular ticket is $10. They sold a total of 40 tickets and made $500 in total. Fun fact, I used our good friend ChatGPT to create this problem. So ChatGPT somehow thinks that you can get a VIP pass to see these two right here.
And they only sell 40 tickets.
Yes,
That's
yes, see? Yep, AI, there you go.
5 billion.
Yep, they sold a total of 40 tickets and made $500. That's all the money that they're gonna raise for charity, apparently. Apparently, all right. For real. Write a system of 2 equations to represent this situation where X is the number of VIP passes and Y is the number of regular tickets. All right, so we need 2 equations. So VIP passes are $15 each, right? So 15X. And then regular tickets, that's Y, or the number of them is Y, and they cost $10 each, so 10Y. And that is gonna equal how much money?
500.
500, just a mere 500. Okay, now we need another equation, so that one is a little bit sneaky. Yes, they sold a total of 40 tickets, so that's both kinds, right? So the other one is X plus Y equals 40, okay?
I remember doing this.
Yeah. So now I'm saying use a graphing calculator to graph the system. You may need to rewrite an equation or 2 in slope-intercept form. Okay, so we can do that. If I want to get this first one in slope-intercept form, I would just subtract 15x. So 10y equals negative 15x plus 500. And then I would divide by 10. So that one is y equals negative 15 over 10 divided by 5. So it's negative 3 over 2. And then 500 divided by 10 is 50.
Y equals negative x.
Yep, and then y equals negative x plus 40. Okay, so if I'm going to use Desmos to, to figure that out, I'm just going to put that in there. Y, I'm just going to type it. Y equals negative 3 over 2x plus 50. And then y equals negative x plus 40. Okay, and then we see nothing because we're just looking at our basic view. So I gotta kind of pinch it. Okay, here we go. 2020. Okay, all right, cool. So I'm gonna write that here. At which point do the lines intersect? 2020. What does that mean? Well, now we have.
Put the solution brackets.
Oh, good question. Do we need to put solution set? So typically for word problems, we don't, because what we're gonna do instead is answer it appropriately. Okay, so if this were just a math problem, solve, oh yeah, I would put it. But now I'm gonna analyze that. What does that mean? That means 20 VIP tickets, or passes, whatever these things are, and 20 regular tickets were sold to support the baby turtles. No, I don't know what the charity is, but that is what. Okay. All right, let's do this. Oh wait, I want to do 7 with you, and then I'm going to let you try the test questions, okay? All right, Anna. Anna's my daughter's name. She's going to be 4 on Sunday, so.
Nice.
Yes. Anna and her friends are organizing a bake sale. They plan to sell 2 types of baked goods, cupcakes and brownies. Cupcakes are sold for $2 each. Brownies are sold for $4 each. They aim to make a total of $100 from their sales. Additionally, they know that the number of brownies sold is 10 more than twice the number of cupcakes sold. Define variables and write a system. Woo, okay, so we were not given the variables to use, so we get to choose them, but we have to define them, okay? So, what are we trying to figure out? How many of each, right? So, let C equal the number of cupcakes. And I'm guessing for brownies, we want to use B?
I guess so.
I guess so. I mean, why confuse it, right? Let B equal the number of brownies. Okay, we have to put this here because we were not told in the problem what variables to use. Okay? All right, so cupcakes are sold for $2 each. Brownies sold for $4 each. 4B. All right, so that's talking about the money, so that has to equal 100. Okay, now here comes the sneaky one. They know that the number of brownies sold is 10 more than twice the number of cupcakes sold.
So 4.
Yes, so B equals, yes, or 10 plus 2C, it doesn't matter the order, but yes. So twice the number of cupcakes plus 10. Now this is not asking us to solve, okay, but we could from there. So this would be our system. Okay. Woo. All right, now a lot of times this shows up as like a test, a multiple choice test question. And they typically are easy, however, all the answer choices can sometimes look the same. All right, so take a second, read this problem, and see if you can find the right answer choice. Okay? So apparently this concert that Julie and Ezekiel are going to is somehow more than Taylor Swift and Ed Sheeran. Yes. Here we go. Relevance. All right, so what do we think? What do we think is the right answer?
D.
D.
I think.
Okay.
C.
Now look at C and D.
And then
C.
I feel like the meme of that lady, like, you know that one? You know that one? Where she- C and D, they look exactly the same.
I read that. I still read it wrong.
I know, right? It's easy, but it's also easy to mess up. Student tickets valued at $12 each.
Yeah, I read that wrong.
Yeah, so that means it's gonna be that one. I know, right? Just gotta be careful. Gotta be careful. Okay, so you can